Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind, doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And I have in the studio tonight Ben, VK7BN.
G'day Justin, again.
How you going?
Very good. I've been a frequent visitor of late.
Woohoo! It's those end-fed half-wave antennas.
Yes. I'm really looking forward to your bit on that later. So.
Excellent,
Yeah.
excellent. The reason you're in the studio is you have a very nice device sitting in front of you.
I have a new toy. We have, which one? Which is this camera? One of the new,
That one.
Yep, iPhone 12 Pros. I'll get you to put on the close-up camera. No?
You can just close it off.
So I'll get you to put that on the close-up camera. So
I'll just reduce the noise there.
So I was one of those people waking up a couple of weeks ago until 11 p.m. and then frantically hitting the Apple site and going buy now to get one of these new iPhones.
Ooh.
And it arrived on time on Friday.
There's my finger.
So I think it's fair to say that that's squashed a little bit on that screen looking at it.
Just a little, yes.
Yeah,
Yes.
which is fine. Probably the notable things about the new iPhone is, one, it's got a really nice stainless steel bevel on it, like the iPhone 4 and 5. So
We've sort of gone backwards a little bit there.
it's gone backwards a little bit, but it's not slippery like the iPhone X's and iPhone 11s were with their glass case. And so it actually feels good to hold. It doesn't feel like it's going to slip out of your hand.
Okay.
They've made some improvements on the camera, which we'll get to.
Okay.
I don't know if we can zoom in on that.
That particular segment?
Yep. So
We can.
what we kind of have
Turn on
there,
some lights.
and with a bit of focus.
Have we got built-in Lidar here?
Yeah. So we have 3 cameras on this one. So obviously you can probably expect when they come out with the iPhone 20, there'll be like 50 lenses on the back. It'll just be a mass. So the three actual camera lenses represent a ultra wide, a wide, and a telephoto lens.
Okay.
I can't actually tell you which ones they are specifically.
No. Okay.
And in the camera app, that basically comes up as 0.5 or zooms of 0.5, 1 and 2
Okay.
to keep it simple.
Okay.
The LED that Justin was just pointing at, that you see on a lot of cameras, on camera phones these days, and they actually use it to adjust the temperature of the image, so the white balance.
Yeah. Okay.
Which is very handy.
Very.
And
this hole here?
so that hole there, that's a speed trap, Justin.
I like it.
Yep. So the new iPhones have introduced Lidar as a Lidar camera into them,
Okay.
which is used to assist with the camera focus,
Okay.
particularly in low light.
Okay.
And of course, the tiny little clear hole to the right of it is just the video microphone.
Right. Okay. Okay.
But the Lidar is an interesting beast. Unfortunately, it's something I can't show you on the TV tonight because I actually have an app on there, and I was showing Justin before the show started of it actually scanning the depth of the room, and it just sweeps through the room. And again, this is going to be used for things such as augmented reality apps for 3D modelling,
3D,
and all that depth measurement stuff. So,
so it'd use it in the 3D picture
yeah.
app. Yeah.
So the technology's in there now. There's not much out for it yet, but like a lot of these things, build it and they will come.
Yes.
So
Well and truly.
I am, of course, desperately waiting to see when we get the best apps for the iPhone 12 Pro pages, and see what we can start to do with it.
And actually, I know what I'll do. Here's an iPhone 7, so you've got a bit of an idea about the difference in size. There's actually not that much difference in size.
Yes.
Hang on, let's go that way. So a little bit different. I've got a cover on this, but it's gone back to that sort of squarish, that iPhone 5 feel, whereas they rounded everything off in the sort of the 6 and 7 and went from there. So very nice, very nice. And you said earlier that it's dual SIM.
It is dual SIM, so nice thing about it being dual SIM for me is that I can use it for work and get a deduction for it.
I love it.
So I'm sure many people who have bought a phone in the last couple of years, their phone will either be dual SIM in that it will take either two actual SIM cards, or it will have an eSIM in it, which is like a chip in like a software SIM.
Yep.
And so I went into Telstra and had my personal number put onto the eSIM, and I've put my work number on the physical SIM that's in there.
Okay.
And what's really nice about it is that you can actually go into the settings and say if I want to go on leave, you can just go in and go turn off the business SIM.
Yep.
Or I can turn off the personal SIM.
I love it.
And it just works. So, but I think what I'm really here for, and what Justin invited me here for, was they've made some improvements, as I said, to the camera.
Some.
Particularly in low light, and that was the first thing I wanted to try out when I got it. So I've brought along a couple of sample images here tonight.
Definitely.
And I'll give Justin those to put on the close-up camera. So what we have here...
So let's go... Hang on.
Yep.
Let's go there. Where are we? Oh, that's better.
Here. Are we there? No?
We there yet? Here we are.
Lovely.
Sorry about that.
No worries. Okay, so what we have here, this is a photo taken in my backyard.
Yes, it's supposed to be dark.
Yep.
Yes.
So that's in my backyard. It's about 8:25 in the evening, so it's pretty dark. There's actually a big concrete wall behind there that actually acts as a shadow. So
I know you don't believe us.
Yeah. So it's actually difficult to see, and I think everyone can appreciate that a camera phone at night is not great at the best of times. So this was taken with my old iPhone X. At that time, just default camera settings, same location, and then I went, and that's the resulting image. And as you can see, it's pretty dark. You've got a vague hint that there's a flower there.
There's a bit of flower in there. There's a bit of light and shade and a bit up here.
Yeah, a bit of light leaking through from the street lights. Yep. So then I took the same photo with the iPhone 12. And as you can see, You can very clearly see the flowers and the weeds and the back wall and the tree hiding it all.
But also those contrasts, where there was light coming through, there is a highlight here and there is some highlights here, which you can see on here.
Yeah.
But that is just phenomenal.
And that very much is... I actually showed a website to the people up in the club rooms last week of a pre-release review of the camera, and we're all looking at the photo taken of a lake between the iPhone 11 and the iPhone 12, and we're going, no, that can't be real, because it was a similar sort of night and day photo like you're seeing now.
Truly.
Yes,
that is phenomenal, Ben.
We stand corrected,
and do you have to do anything to get it to do that, or does it just do it?
It will do it automatically. It just detects night. It's dark.
It's low light.
You use night mode. The only thing it does do in the camera is say, try and hold your camera steady for about 3 seconds, and it has a little marker on the screen.
Okay.
It's not too fussy about that.
Okay.
Apple tend to boast that it uses AI to align all the imagery.
Okay.
And we'll probably show that a little bit in the next photo as well.
Oh, okay.
So the other thing I actually tried to do was a long exposure using the default camera app. So this for those who know Glenorchy is Glenorchy Falls, or Humphreys Creek Falls, which are up at the far end of Chapel Street.
Okay.
And you literally drive past the.
I didn't even know there were falls up.
Yeah, you drive past the tip, almost to the end of the road, and you can see this from the road. And when you park in the car park, you're maybe 10 metres off the road from this wonderful waterfall.
Okay,
it's really worth going to see.
Cool.
But this photo is taken with the live photo technology of most even iPhone 7s, 8s have the live photo functionality.
Yep.
And the idea behind that is when you take a photo, it will take a couple of seconds of video as well.
Yep.
And then when you pass that photo to whoever, they can push and hold on that photo and all play a bit of the video, and that's meant to be lovely according to Apple. But if you swipe up, it also gives you some effects you can apply to it, including the ability to loop the video, to
jog it,
jog it backwards and forwards, and to create a long exposure.
Okay.
So what I believe this is doing is taking that 2 seconds of video footage, 30 or 60 frames per second or whatever it is, and then just merging those frames into one image.
Okay.
So I mean, in this, it's a pretty good photo. I mean, this is handheld, and with a traditional camera, good luck trying to do this handheld. You'd need a tripod.
Because you've got multi-second exposures involved. So
for those who know my photography stuff, yes, I had my SLR camera with me as well. That was very much on a tripod.
Okay.
But I think for the average punter who wants to do a quick long exposure to remember the awesome waterfall while they're out travelling, they're not going to care too much.
Oh, well,
that comes out really well. I mean, if you look at it, you can see a little bit of horizontal striping midway through the waterfall, which it is a bit of a limitation of that merging.
See it through here.
Yeah. And that's obviously something you don't get with a traditional camera.
Yeah.
If that bothers you, get a traditional camera.
Correct.
Otherwise, most camera phones these days are really supplanting the need to carry a full-on camera kit if you just want to do a casual photography.
So Ben, you pointed out the 3 different lenses on the back here.
Yeah.
So the ultra, the wide, and the normal.
Yep.
Do you have to select, or can you select those?
You can actually choose those
in
the camera app as to which, again, your zoom will be 0.5, 1 or 2 for telephoto.
Okay.
And it's just like taking a normal photo. You just click the button and it does its thing.
Okay.
So
that's pretty impressive.
But again, because I'm a bit of a photography buff, I do have a little sort of flexible tripod I use for holding the phone up on my desk, and it's got a mount for the phone.
Okay.
So I mainly use it for FaceTime and Facebook Messenger video calls and things like that. But again, we'll probably be taking this out with me when I go on my photo trip, have the tripod there, and I'm just going to experiment and see what happens.
Fantastic.
So
Now, I assume this is 5G?
it is 5G. So it's 5G with a catch at the moment. There is there's a software update coming.
Okay.
At the moment, when you have two SIM cards in it, being the eSIM and the physical SIM, it will do 4G. It will drop back to 4G.
Okay.
But if you disable one of those, it will go back up to 5G.
Okay.
Needless to say, I've just come back from a week's leave, so I've had the business side of it turned off, which meant I've had 5G.
And what are you getting in the way of 5G downloads and uploads?
I think there'll be a lot of people on the mainland jealous. I think there'll be a lot of people with fixed wireless and fibre to the node who are jealous. I was getting a very casual 305 megabits download speed. Upload speed was a bit more of a paltry 20 megabit, but again, for mobile use, you're probably not using the upload side of it.
Yeah.
You're probably consuming. So that compares to maybe 25 to 30 megabit on 4G LTE.
Wow. Okay.
It's a cool bit of kit. It's certainly an expensive bit of kit. It's been the one treat I have bought myself for this year, and sort of at this point of this year, I really needed a treat. So
it's a sexy bit of kit.
So yes,
very nice. Very nice, Ben.
That is the new iPhone 12. I'm sure people will be interested in seeing more from it.
It's still a lightning connector?
It's still a lightning connector, which was a bit of a surprise.
Yes, yeah. They haven't changed it.
We're really expecting USB-C with it this year. Particularly with all the iPad Pros have now gone USB-C.
Yeah. Okay. That is a bit of a surprise, actually.
Yeah. It's lucky it came with one because there's a fair bit of talk at the moment that they're actually going to do away with the connector entirely. It was all going to be wireless charging, which was going to be painful because they don't supply a wireless charger.
Yeah.
So,
but you can wirelessly charge them, I assume.
Most definitely.
They have got the induction coil and all of that sort of stuff built in. So
that's one toy I haven't gotten yet. So
yeah, and I wish you luck on the RF.
Yeah,
but,
exactly.
Anyway.
That's why I haven't gotten one of those yet.
That is fantastic, Ben, and I'm green with envy. So I'll give it back to you now.
No worries. So that's it from me. Thanks for having me on again.
No, that's fantastic, and we'll have our NFED half-wave update towards the end of the program. So I look forward to that. Thank you very much.
No worries. I'll catch everyone next time.
No problems.
Cheers.
Thanks, Ben. So we have. We'll get. Oh, can you just snip that locked?
There we go.
And we'll get Rex in. We'll get our next person. No, just close the door because there was some very loud talking. So now
you can come over here, I think.
Yeah, well, you can bring your chair over if you like, Larry. And we can't quite do a three-person because my lens is not quite so quite so wide. But I can move them remotely because our remote camera is
it's okay.
So welcome to Rex, and also welcome to Larry there, VK7WLH. I'm not sure that we've had Larry in too many times. We've had it in a few times. So excellent. So welcome, Larry.
Yes.
It's neither of your birthdays, I assume, this week or today.
No.
I'll just point out that it is actually Murray VK7ZMS's birthday. And it is a significant birthday. It's number 50.
50. Wow.
Murray, if you're out there watching the DATV on your birthday, please stop and enjoy your birthday. But
a mere child.
But he's having a significant birthday tonight, and I understand Richard probably will be celebrating with him.
That's why we haven't got Richard part of this talk, which we
Correct.
should have had.
Correct. No. I was hoping that we were going to get the three of them, the three of us together with our RD contest certificates to take a historic or hysteric, either way, it depends on how you look at it, picture of first, second and third.
Oh, right.
Given
to VK7.
to VK7, and that was going to go. It probably still will into the next AR magazine, but anyway, so we'll just rub it into the mainland. So I have Rex and Larry in here to give us a optical update. So I'll go across to Rex.
Thank you, Justin.
Now you want your presentation.
We want the PowerPoint, yes.
That's all right. I'll just get that up and I'll put it. There we go. Put it on to. We'll whiz across to. Oh, actually, no. Actually, I can do this. I have the technology. Let's go to. Oh, look at that. Now, if I do this. Ta-da!
Okay. Justin asked me if we'd give an update on what's going on with Optical, and the reason we've got back into Optical is that Joe Taylor, getting back a couple of months ago, released a new version, a new mode for WSJTX.
Yep.
Called FST and FSTW. These modes are primarily designed for LF, although I noticed a lot of people experimenting up to even 40 metres.
Okay. Cool.
Providing their rigs are stable enough.
Funny about that.
We did test these modes at 10 gigs and they certainly weren't suitable there.
Okay.
But
however, they are suitable for
They are
much higher than that.
they are suitable for Optical. Now one wonders when you go up to so much higher why it would still be suitable in terms of stability, and the reason is Optical is actually AM,
Okay.
and so the stability is in relation to the AM carrier, which is 0 hertz baseband.
Yes.
And so it's only the sound card that's got to be stable.
Yeah. Okay. Cool.
Now it's the slide.
Let's go to the slide, which is here. Yes.
Oh.
And
Yeah.
okay.
Yeah, just a note on optical gains, because it's often, well, it's still confusing to me. Optical detectors work on the basis of turning photons of light into current, and because the power is proportional to the square of the current, that means if you double the current and therefore get a 3 dB increase in current, you get a 6 dB increase in the signal to noise ratio, or the power at the other end. It sounds like something for nothing, but we have done this so often, and we're prepared to accept the something for nothing.
Correct. Yes. Mind you, it happens in both directions, which is a bit of a problem. But anyway.
Yes. If you reduce the power by half, it costs you
it's a quarter of what you.
another 6 dB.
Correct.
So, but
Anyway.
so as we go through this talk, when we talk about the gains, they're in relation to what we receive,
Yep.
and so if we talk about, say, a 10 dB improvement, that's resulted from a 7 dB improvement in the actual LEDs, and the other 3 dB is because of the
power transform.
yeah. Okay, next slide. The new WSJT modes, they get down to minus 45 dB, which is the attraction.
However,
But it takes 1800 seconds for each TR period.
okay.
Now that's all right if you're just trying to break an optical record.
Yep. Yeah.
You're not going to have a lot of QSOs sitting there rag chewing.
For half an hour.
No, that's only for one over.
One cycle.
Yeah. But the modes do provide periods right down to 15 seconds.
Okay.
So there are sensible QSO modes for people who want to go faster.
Yeah.
But the sensitivity drops off. So if you want to work at 15-second periods, you
Minus 20.
Minus 20.
Okay.
1800 seconds minus 45.
Yep.
Unfortunately, the other penalty with the 1800 second period is you need stability better than 0.05 of a hertz
Yeah, okay.
for the 1800 second TX period.
And LF and MF, actually, that's not quite so hard.
No,
Yeah.
and certainly it's not so hard on getting a sound card for that.
Correct.
accuracy.
Correct. Okay, cool.
But we'll compare that with.
But that's also, actually thinking about it, that's also half an hour of your transmitter being on for half an hour.
And stable for within 0.05 of a hertz for half an hour.
Yeah, that's a bit challenging.
Yes.
Okay.
I think you can easily do that on LF if you've got
Yeah.
a particularly if you're GPS locking.
Yes.
Yeah.
Yeah. Well and truly.
Uh,
And you're using a commercial NDB transmitter, which is 100% duty cycle.
Right. Yes, because you're going to have to run for a long time.
Correct.
Okay. It only uses 4 tones,
Okay.
so it's a very narrow occupied bandwidth.
Very.
In fact, each time you sort of double the speed, you double the bandwidth.
Yep. Okay.
But in the 1800 second period, the total bandwidth's only 0.36 of a hertz.
Can fit an awful lot of signals in
Yeah.
bandpass.
Slow signals, but a lot of them.
But a big advantage of all this is on optical, where you've got the band full of QRM from 50 hertz lights and 60 hertz
Yep.
pictures, is you can easily fit 0.36 hertz
Well, truly.
in between all these interfering signals.
Yep. Find a spot.
Yeah.
Okay.
Next slide. In basic terms, FSTW is 1.4 dB more sensitive than the old Whisper.
Okay.
There is an explanation in Joe's notes as to why. I will repeat the words. I haven't a clue what it means.
Single block detection.
Because he uses multi-symbol block detection, he gains another 1.4 dB.
Great. Moving on.
Yes. Comparison with WSJT.
Oh, yes.
Now,
I remember that.
right. Very few people do.
No.
But WSC was called Weak Signal Communicator, and that was developed by VK7MO
Yep. Tape.
specifically for our light work.
Across the street.
And we did get some good results with that. 288 kilometres across Bass Strait, one way.
Yep.
Because we'd only built one transmitter and one receiver.
Yep.
WSJT used 3.8 millihertz tone spacing, and effectively what it did is it transmitted single tones on a total of 36,000 separate frequencies spaced 3.68 millihertz apart.
Yep.
And each single
For
tone,
each character.
not each character, actually each group of half a call
Oh,
sign.
yeah. Okay. Okay. And the
Because
combinations
half a call sign represents about 18,000 options.
Yep.
So
Yep.
it's one single tone for option. So it didn't have any
Yep.
Ford error correction like
WSJT.
WSJT. I mean, for its purpose, it worked really well.
It
but
Had to GPS lock the sound card though.
that's right, because you were dealing with 0.38 millihertz, 3.8 millihertz tone spacing.
Yes.
So WSC required 137 hertz of bandwidth,
Yep.
which meant
It's still a narrow bandwidth mode.
it is, but it's very hard to avoid some of these 50 hertz harmonics and 60 hertz harmonics if you want to be that wide.
Yep.
Whereas FST, just 4 tones, 3.36 hertz apart, and you can fit it in anywhere.
Yeah. Fantastic.
Okay, so the advantages of FST is the narrow bandwidth,
Yep.
The Ford error correction to avoid false decodes.
Yep.
In some ways, WC had avoided false decodes because you knew what the station's call sign was and what tone to expect, and as long as it looked reasonably stronger than the ones that you didn't expect, you assumed that
it was the signal.
Which
No.
it's just the same advantage that
Search.
deep search or
That's right.
CW, whether you're in a skid or anything else.
Correct.
A big advantage of FST is it uses standard WSJT exchanges, which everyone knows and understands, and it doesn't require GPS locking like of the sound card like WSC. So I think it's a significant advance.
Definitely.
And it's going to prove very useful.
Okay.
Next. Now, the longest distance we've done so far with FST is 153 kilometres. That's partly because with COVID we can't go across Bass Strait until the borders open up. But before we do go at the trouble of going off Bass Strait, we want to improve the systems as well.
Yep.
But the sort of exciting bit of this is, this was a distance of 153 kilometres. It's non-line of sight.
Yep.
Because the Google Earth overlay doesn't take account of Earth's curvature.
Yep.
And we were actually able to use it right down to the 15-second periods.
Yep.
And get decodes at minus 14 dB.
So still a mountain of headroom.
That's right.
Well,
Now, whether we were lucky and there was just a cloud that was in the right place at the right time, but it did last for a long time, I'm not sure.
that looks very promising, Rex.
It does. Next slide. After Richard finished at Mount Wellington, on the same night he went home. Now his home location
Is much worse.
is dreadful in terms of takeoff, and yet the signal's improved to minus 13 dB.
There's a mystery here.
Well, part of it is the distance is a bit shorter,
Yeah, correct.
but obviously
Even if you take into consideration the curvature of the Earth, it's still terrible.
Right.
but one can only assume that in fact there was very high level clouds that we were using, which were line of sight both ends.
That may be improved.
Yes.
Oh, so that's
Next slide.
puzzling.
Now, FST is very close to the Shannon limit.
Yep.
I mean,
Now, explain the Shannon limit for those people who don't know.
that's a hard question.
It's this theoretical information transfer limit based on the system characteristics. Is that right? Is that a...
Well, it's based on primarily assuming you've got plenty of bandwidth.
I just want to know what the Shannon limit is.
Oh dear!
Has it got to do with the hydro?
No.
It's not Shannon tier. No.
Well, we better give Claude Shannon some credit here.
Yeah.
Oh, definitely.
Claude Shannon worked for the Bell Telephone Laboratories
Yes.
during the World War II, and he was trying to work out what was the maximum amount of information you could get down a telephone line, because this was worth money to the Bell Telephone Laboratories. And he produced a paper called something like a mathematical treaty on information,
Yep.
which has stood
This test of time.
test
Yeah.
of time, and
Well, truly.
it basically derives the amount of information you can get through a bandwidth with no errors, providing you have an appropriate code, which he didn't derive,
Yep. Yeah.
but he just said, if you can find this code, there will be a limit
This is
by
the maximum you can put down that line.
that line. And so clever people are trying to get closer and closer to the Shannon limit, and good systems can get within about 1 dB of the Shannon limit.
Wasn't true.
There are, and while I haven't done the sums, I suspect FST now is so close to the Shannon limit that even if we make a spectacular improvement in coding, we might gain another 0.2 dB. And
Yep.
so if we're going to do anything to improve these systems,
It's diminishing gains from here on in.
yeah, it's got to be done a different way. And
Correct.
that's either more optical power,
Yep.
TX power,
Yep.
more receiver sensitivity,
Yep.
and there we start to get limited by external noise and physical size of Fresnel lenses that we're prepared to use.
Yep.
Even though
I
we're
still have to meet a square one in
so
the
do
shed.
I. So do I. And I've been trying to work out how I could put that in the back of the car.
Yeah, okay.
Yeah.
Okay, I can put it in the back of the van.
Yes, you'll be all right.
Yeah. Okay.
But Larry is going to talk about some big advances in detectors that, depending on whether you're limited by external noise or noise in the detector,
Yep.
might well offer some improvements.
Okay, cool.
And the last bit in that one is propagation, because
No.
we're
yes.
really guessing on propagation. We just don't know how often you can get a cloud in the right position at the right height without some other clouds lower down in between.
Yeah.
And some of the meteorology behind that we need to do a lot more work on.
Yeah.
Now, in terms of improving TX performance, back 10 years ago, the way we did this, we produced what we called a cloud burner.
Yep.
And this had separate Fresnel lenses in front of each Luxeon LED and produced a beam width. I noticed in one paper I said 2 degrees and another paper I said 1 degree, but a very narrow beam width,
Correct.
which means all the energy was in that narrow beam width.
Out the front.
And in theory, it should have been a lot more gain than the Luxeons,
Yep.
which had a 10 degree beam width. And
There was a secondary lens in there, though.
a torch type secondary
Correct.
lens,
That brought it down to
10 degrees.
yeah.
Yeah,
So
to get onto the
So
Fresnel lens.
because the Luxeons are 180 degrees normally,
Yes,
so that lens at least brings it down to 10, which puts it onto the back of the Fresnel.
yeah,
So you're fully illuminating the back of the Fresnel.
that's right. So that was one system. We've had a look at these Phlatlights, which you can actually put 12 amps into a single bloody LED.
We'll show you one in a sec.
Now the other problem is, in the last 10 years, these Luxeons have become obsolete, and they've been replaced by a Rebel, which you can only run
With a cause or without a cause?
you can only run half the maximum current rating as the Luxeon, and that sort of put me off a bit. That if they were much lower maximum current.
Yes.
No, next slide.
However,
Now, in terms of our cloud burner, I did a test, which I never did before, because before, as soon as I got the thing working, I went for Bass Strait and we got the 288 kilometres.
Yep.
But I did a test with Richard. Now, it may not be representative of a long path,
okay.
but it was 12 dB worse than just using the torch lenses on their own with the wider beam width.
Yep. Fascinating.
Which didn't make any sense.
Yep.
So there's a little bit to learn there, which we should put some effort into. But at least superficially, it looks like you're better off to just use the torch lenses, which are much more convenient, because the cloud burner
We'll show you.
is so big you can't put it in your car. And pretty hard to manage. So we're looking at the torch lenses as the way to go.
So what you're saying is we could have had something that was much smaller and easier to handle and probably done better. Maybe.
Yeah. And if we'd only taken the other one at the same time.
And done a comparison.
And done a comparison.
Okay.
So, next slide. We've had we tend to do all these tests through our windows, because it's cold when you open the windows, and insects fly into lights and or stuff. We found that Richard's windows cost 5 dB and my windows only cost 2 dB. Now that's a surprise because my windows are the what they call comfort plus, which is a multi-layer thing.
Okay.
Which stops,
Coating on the windows.
well, it's stopped.
Or it's built into the windows.
It's sort of a layer of glass, a layer of plastic, a layer of glass. To try and make it like
Okay.
a multi-flat pane window.
Double glazing sort of stuff.
And I know, and it must have a tint in it because I know it costs about 10 dB at 10 gigs and sort of about 20 dB at 24 gigs.
Ouch.
Yet it only costs 2 dB at 474 terahertz.
Okay.
Now, the reason for that may just be that I'm actually limited by the external noise, and the external noise from the lights
Yep.
is limited mostly just as much as by the window as the signal, and so the signal to noise ratio doesn't deteriorate.
And it's can I just say it's the lights from most of Hobart.
Well, the northern suburbs,
Correct.
yes.
So
Yes. So we've when we're really trying to do long distances, of course we work outside and we don't have window lights, but it's worth.
and in the dark. And
That's right.
in
Oh well.
locations.
Yes.
Correct.
Next slide. Now a new sort of LED became available since we did that earlier work called a Phlatlight. Well, I'm not sure I'm pronouncing it right.
No, that's right. That's a flat light. Yeah.
And we thought, now these are capable of handling enormous currents like 12 amps peak, and we'll show you one.
Yes.
Over there.
Cool. No, we'll show it.
Oh.
We'll show it in a sec.
I'll show it. Okay. And I got one of these surplus with a lens already on it, and it seemed to have about the same beam width as the torch type lens.
Yep.
So I was expecting it to be with the same current as a multi lens,
Yeah.
about the same. It is.
And that lens coupling seems to be quite good. You know, there's no loss. There doesn't appear to be any loss because it's actually the lens is glued onto the top of the
Yes.
flat light.
So there's a slight difference in frequency, wavelength, like it's up at 650 nanometers compared to the Luxeons at 627. But given that the beam width was similar, I'm expecting about the same result.
Yep.
Well, I was 8 dB down, and I thought, well, this doesn't seem the way to go. I mean, it would have been a lot simpler to just have 3 or 4
bank of those.
bank of flat lights rather than a bank of
Yeah.
60 LEDs like we have at the moment.
Yep.
But at least my conclusion is.
Now the interesting thing, Rex, is I seem to remember reading somewhere with the flat lights and the lens assembly, there was actually optical liquid that you put between the lead and the lens, which is an optical coupling liquid.
Oh, okay.
Now, I and that's why I was interested in how that was mounted. I wonder if they've glued them on and not put the optical coupling liquid in.
Well, that might be part of why they were available surplus.
And they may have forgotten to do that and thought, oh, bloody hell, we'll just sell them.
Yeah.
Or something like that. But
Okay.
I seem to remember.
It might still be worth somebody experimenting with flat lights, but
Yeah.
so far they don't look like an
Yeah.
option.
Okay.
Next
Cool.
slide. Now, the new Rebels, even though they're only half the maximum current, we started off doing some tests, and what I did is I set up 2 transmitters, and one of the things that's important with 2 transmitters is you have to have exactly the same mark to space ratio on them both.
Yep.
And to do that, I used a zero crossing detector, and to get good zero crossing, you've actually got to use an op amp with both plus and minus, so
Yes,
that
so you can get it to...
get to cross.
Yep.
And we've been using that to compare the Luxeons and the Rebels.
Yep.
And the surprise was the first line there, you'll see we put 375 milliamp through
Both? Yep.
both of them. the Rebel was 8.5 dB in front. Now that really means about 4 dB more of optical, but you know.
Okay.
Then we put the Luxeon
on
up
the
to
Luxeon
up to 750 milliamps, which is the maximum rated value for both of them. 375.
Yep, is in the middle.
Yeah, I mean the maximum's double that, but given this is the average with the square wave.
Okay.
And the Rebel was still 3.5 dB in front.
Okay.
Then I pushed the Rebel way up
To its maximum.
well beyond its maximum to 750 milliamps, and the Luxeon up to so that's about 3 times its maximum.
Yep.
And the Luxeon up to 1500, which is twice its maximum, sort of waiting for something to fuse.
And the light to go off.
And the Rebel still
Well, I'm sure.
3.5 dB in front. Then I thought, well, I will compare the two at the same current, noting that both of them are going to be way over their maximum current,
Yep.
but the
Yeah.
Rebel much more, which is sort of comparable with the first line, and yet the first line it was 8.5 dB in front, and by that time it's 10 dB in front. Now that suggests to me that the Luxeon is starting to get close to its maximum and is levelling off.
Yep.
And the Rebel, even 3 times
It
its
keeps
normal
going.
maximum current, is still
Still putting out
going. Then I compared the Rebel at 655 nanometers
Yeah.
with another Rebel at 627, which is
Same as the Luxeon.
the Luxeon that we used in the past.
Yep.
And the Rebel was up 3.5 dB, as the 655's up 3.5 dB. So that suggests that some of that improvement,
Is your sensitivity of your receiver wavelength?
or the propagation.
Oh, okay. Okay.
Remember
So this is between you and Richard.
between
this
you
is-
and Richard and I.
Yeah,
Yes.
Yeah, okay.
However, that's a fairly short path. It's only 22 kilometres. Remember we did a 160 kilometre path and compared blue and red, and there was about 20 dB of difference.
Correct. Theoretical
So-
difference.
Obviously, the longer the wavelength, the better chance you've got of getting red through.
Yep.
That's the reason the sun looks red when it rises in the morning, and
Yep.
the moon looks
And
red.
sets. Yep.
So longer wavelength probably is part of the reason
Okay.
that it helps.
Okay.
We never could get a longer wavelength Luxeon, but we didn't even think about it. So part of it is that, and part of it is just the efficiency of the Rebel and the fact that you can push them so hard.
Yeah, and they just keep giving.
Yeah. The next step, if Richard had been around tonight, would have been to push the Rebel even harder.
And see whether it keeps going.
Because I mean, they're relatively cheap, so I'm prepared to push them until they fuse.
Yeah, okay.
But I suspect there will be a time before they fuse where they level off.
Yeah.
And
If you can plot that, you might be able to say.
now, I suspect the rating is based on the fact that they're trying to achieve a certain lifetime.
Yes.
And the lifetime on LEDs is sort of 100,000 hours or something.
Yeah.
It's not such an issue for us because we're certainly, if we run for more than a few hundred hours, we'll have spent a lot of time out in the field.
Correct.
So there's a lot of scope for getting some more out of these by just pushing them to the limits.
Well, and by the look of it, you can actually run them like peak current, much higher than what they're rated at.
Yes.
For short periods of time, which that may work in your favour.
Well,
so.
I'm not saying short periods of time because we're talking 1800
correct,
seconds.
yeah. No, correct.
So next slide. What I did then is I ran the thing at that high current, 1 amp, through the Rebel,
Yep.
3 times its maximum rating, to see whether it dropped off over the evening.
Yep. Okay.
The blue graph is relative to the Luxeon.
Yep.
And it's basically sitting. Unfortunately, WSJT only measures in 1 dB steps.
Yep.
And it's flicked from 9 dB to 10 dB most of the time to occasionally 11 dB in front
Yeah.
of the Luxeon, and it hasn't dropped off over a whole night,
Yep.
running at 3 times its rating. So I think it's still got a lot to spare.
It's got more to give.
How much of that power is wasted, has lost its heat? into
About
the heatsink?
you get about 30% efficiency.
Oh, right. That's quite a lot then.
Yeah.
So the heat
Uh,
gets
it is important to fan cool the heatsink and have good heat sinking to get LEDs to work properly.
correct.
Do the specs give you an operating temperature at the junction or anything like that?
Oh yeah, there's a whole lot of data that's
Yeah.
like that you really should take account of. But
And in fact, lots of the development kits provide, there's a little thermistor on the development kit. on the
to see
actual-
whether it's getting too
correct.
hot. Yeah,
Correct.
yeah. But basically, I put a really good heat sink on them, and then I put a fan on
Fan.
that runs pretty hard,
Yep.
rather than doing the calculations. So I just
Yeah,
hit it hard and keep
No,
it as
get rid of the heat.
You
Oh,
do
sure.
a negative temperature coefficient just a little bit, so when they get hot, the voltage drop, the same current drops down a little bit. Or you run it through a current,
we
current driver.
there might be some small variations like that, but they're not great.
No.
No.
And see, the commercial control of them are constant current controllers.
Oh, right.
That's how they control them
Yeah.
normally. Well and truly.
Now the red graph there is the actual signal strength that I was getting at my place from Richard's,
Okay.
and you can see that's peaked up at plus 4 dB.
Wow.
That's a strong signal
That's-
on WSJT.
That's an off-the-show signal.
You know. Now you see the signal rose at the start and decayed at the end. That's when at dusk and dawn.
Oh, okay. Yeah.
And
okay.
and in fact, at the end there, it was still decoding. That was about 10 to 7 in the morning, and it's quite light at
Well,
at 10 to 7.
Sun rises at 6 o'clock these days.
You know, at 10 to 7 in the morning, and it dropped off dramatically because it's
noise.
competing with this great noise source that somebody puts up there every day. But but it was getting through.
What's the nudge?
I don't know, but it's probably to do with clouds. The trouble is, you can't see what's happening with the clouds in the dark. The only way you can sort of tell is you look for stars, and if you can see stars, you assume there's no clouds. But we certainly know that if the cloud layer drops below Mount Direction, which is between Richard and I,
Yep.
then you get nothing.
Yeah. Okay. Full attenuation.
Okay, next slide. Now, the people that make these rebels, and they provide 3 base options.
They look like Luxeons.
They look like Luxeons. Oh well, it's the same company.
Oh, okay.
Oh, yeah,
Okay.
So it's,
Okay.
or you know, if you go into their website, they say, and you ask for Luxeon, it says this is now obsolete.
This is now.
Recommend you try a Rebel.
Okay.
And then you look at the spec for the Rebel, and it's only half the maximum rating. You think, oh, what
What are you doing to us?
What am I doing? But the reality is, it's better than the Luxeon, and one can only think this is Moore's law that
The technology. Yeah, it's
the
better
technology's improved.
Okay.
Now they offer these 3 types of bases, and I originally thought the Sabre was going to be better because they sort of quoted it, the rating, even though the actual maximum rating was the same, their examples were at a higher current.
Okay.
But the more I think about it, I think I should have gone for the ThinkPad, which was another 25 cents each.
Right.
By the way, I'm getting some ThinkPad versions which are about to arrive. They got rejected by customs.
As
And
lasers. No.
I'm not sure, but they wanted the supplier to define exactly what they were.
Okay.
he'd only called them electronic components, you see.
Oh, yeah.
But fortunately, when I got home this afternoon, I noticed they've been cleared,
Okay.
and they had to actually describe them fully as, except
LEDs.
I don't know who mucked it up, but that's called a sync pad, and the way it got on the customs document was a slink pad. That must have convinced the customer.
They may have thought it was something from an adult shop.
Yeah. So there's two options there, which hopefully within a day or two we'll have both,
Okay.
and we'll push the sync pads
Yep.
as hard as we can to see whether they
Yeah.
are even better at being driven.
Cool.
Next slide. Now there is a 735. Given that going up from 637 nanometers to 655 gave about 3 dB improvement, one wonders whether going up to 735 Rebel will even be a better improvement.
Okay.
Particularly if this is due to propagation, because
Yep.
if it's due to propagation and we're getting 3.5 dB on a 22 kilometre path,
Imagine what you get on a longer one.
what improvement were we going to get
That's
on
right.
a long path? There's a couple of problems. It's only available on a sync pad mount, and I'm not sure whether the sync pad's better than the Sabre or the other way around. But at the moment, I think sync pad might be better,
Okay.
so that's probably all right.
Cool.
And it's a bit of a problem with my APD because the spectral response drops off.
Yeah, the same problem we had with the photo multiplier tubes.
Yeah.
They were pretty
Okay,
narrow.
so the next slide is there's another company that produces LEDs,
Cree.
and Larry has been investigating them. They're potentially even higher power, and they come with a 5-degree lens against a 10-degree lens, which in principle sounds like they would be better. So over to Larry.
Okay. There you go. That's a good one. This will be number 2.
What did I just do?
You had it first. There it is. Well,
Yes, I had it for a little while, don't worry.
now, this is not exactly what we would order. This is simply an example.
Okay.
And this is from an outfit in Melbourne and called Cutter. And they actually will provide assemblies.
Okay.
So I told Rex I was going to buy 500 of these and put them on a big circuit board, and we'll see what we got. Now, these are little modules that are not dissimilar to what he's currently using, but we would be putting a Cree, what's called a photo red, and the new photo red designs are 660 nanometers,
Okay.
and they're producing them like M&Ms because they're used in plants. They're used for plant growing.
Oh, okay.
No
Okay.
doubt,
Yeah.
increasing the level of plants in marijuana in the
Those-
United States.
those
but
plants,
yeah,
yeah.
I thought that might be my customs rejection.
They've got a hotspot on
yeah, right.
LED sales,
So-
white light LED sales.
Now, the ones that we're going to be using, the Crees, as testing, are $5 for the chip, but you can see there's a mounted version of something on there that's only $385. So we're not talking about a lot of money.
Okay.
And so they will provide them in the formats we want. So
Okay.
this is another version of something else, but I just wanted to...
Yeah, that looks more like the Luxeon
yeah,
mount.
There are standard mounts, of course, and what I wanted to show you was that, which is the spectral distribution of red. It's right at 660.
This is the red, and that's the blue.
Yes, so considerable
Just-
difference.
Just so you can actually see this.
I thought it'd just be narrow lines.
660. So that, yeah, okay.
Now those are two different devices,
Yeah, yeah.
optimized
No,
for
no,
two
well,
different frequencies. Yeah. Here are the same devices with the relative outputs, but if you notice that the red one, I've
Which is
drawn,
the top line.
yeah, that's being hammered at, what is it, 400% of its normal.
Well and truly.
Yeah, so you can probably go up quite a ways in
So they've actually tested them 400% above their maximum rating.
yeah,
Oh well.
Well, anyhow, that's 1500 milliamps. So
Well, that's
That's a hint, isn't it?
Yes.
That we can afford to go even further.
That's right, 1500 milliamps, and it's giving what 420, 430% over their relative radiant flux.
And it looks linear, so it
No,
doesn't
well,
seem
truly.
like it's levelling off.
yeah, I
Correct.
thought you'd like to see
It
that.
just
Yes.
keeps going. The interesting one with the blue, that just keeps going. That's off scale.
Yeah.
Now, again, this is all early days,
Mm.
so this isn't necessarily specifically what we're going to get, but this is some lenses which are available, and they're like $1. I don't know if you can.
Yeah.
Now, do they come with mounts?
Yes.
Yeah. There's a whole family of
Little
stuff.
plastic-
That's the same. That's the same here.
It'll
Yeah.
have a little mount under it.
Yeah.
Yes. Oh, yes. They show you the
Yeah.
mounts. Yes.
Now this
You
one,
probably have to buy the mounts as well.
yeah, but it's all peanuts. I mean, it's,
Yeah. Oh, yeah. We're going to make sure they come. That's all.
Yeah. Okay, so you can see that there's a 20 millimeter series, and they fit Luxeons, but essentially what they've done is like everybody's making more or less the same mount,
Yeah.
unless it's a special order item where they don't want you to be using the wrong stuff.
Yeah.
Now, these are the lenses, and
Oh,
what's
okay.
interesting there is they have a
15,
spot with a
25.
5 degree, and then they have all the way up to a 25, and then of course there's a 5x20, which is used for particular illumination issues. Notice the distribution. If you move it up a little bit, there you go. That's the 5 degree lens.
Wow.
And the half angle divergence is over there in the other chart, which is too small to read, actually.
Now, the advantage of 5 versus 10, that should be the area of the beam should have gone down by a factor of 4,
Right.
and the current with the so that's 6 dB, and then because it's current, you should get 12 dB improvement by going from 10 degrees to 5.
Oh.
If everything else is equal. Now, we didn't get that with the cloud burner,
Yeah.
but
But we also didn't measure it at the time.
no.
Anyway, things you learn.
Yeah.
So what I'm going to be doing is, with Rex's advice, I'm going to be ordering some sets of these with 5 degrees and 15 maybe.
Oh,
And-
I think you just go for 5.
Okay. Well,
Yeah.
you wanted to see what the 5 10 would be like, so.
Well, yeah, but I think given that they don't have a 10, I think just go for 5, and we'll compare it with the
10.
Yeah,
we've got.
the Rebels.
Yeah.
All right, so I'm going to be ordering a set of these, and these guys are very cooperative. They think we're doing interesting stuff, so at least the designer does.
Cool. This is probably a good time to show the
Yes.
actual devices.
Yes.
So I'll give Larry back those. So this will go with. Zoom in here because it's weenie. So what are we looking at here, Rex?
Now this is the so-called Phlatlight, which you can put 12 amps peak into it, which really means 6 amps average with a square wave.
Solid copper.
It's got a solid copper, I think it might be gold-plated
Yeah.
aluminium heat sink,
No, it's
which
copper.
you
It's the weight.
okay,
It's the weight.
which you actually stick to a big aluminium heat sink with that thermal tape, of which a bit of it's still stuck there, because I removed them when they didn't work all that well and replaced them with the Rebels.
Yep.
It's still possible that Phlatlights are worth experimenting with, but the moment I don't see it as a priority.
Yeah.
How
I think-
old is the technology?
Well, it's probably Luxeons. Luxeons were originally produced by Philips 20 odd years ago. It would be, I reckon. That was
Well, yes, because Mike was using them a long time
Correct.
before us.
correct. So it would be probably 10-year-old technology.
How bright are they?
Very bright.
Supposedly,
But you're putting 12 amps,
you're putting
6
12 amps through a.
But keep in
LED.
mind that the Rebel versus the Luxeon is half the current.
And more,
Yeah, so I'm just wondering how efficient it is.
Well, and that's why I'm a bit surprised. I'm actually a bit surprised because the Phlatlights were supposed to be the
Be all and end all.
saviour of the world. Yeah. Anyway, So this is
This is the old Luxeons that we used in the past.
with the lens on it.
with a torch type lens, so
Yeah.
people are aware of what a torch type lens is.
So you can
and that's a 10-degree beam width.
you can see. Hang on, there we go. You can see the mounting plate of the Luxeon here, with its characteristic mounting holes and bits and pieces, and then that's the sticky tape that it's stuck onto.
Thermal tape. Yeah.
Is it
So-
typically 2 volts voltage drop across it?
About 3.3.
Yeah.
Oh, right. At 12 amps, 36 watts, just for a little while.
No, for a long while. What? Sorry, 12 amps peak and
Oh,
6
6.
amps average.
So about 18, 20 watts.
Yeah. I think you possibly could run it at 12 amps peak if you didn't want to modulate it.
Oh no, well that's what I think. It's peak
Yeah.
through current is 12 amps. You can run it at 12 amps if it's
Yeah.
got a suitable heat
But
sink on it.
yes, you got to get the heat sink because
Get rid of
about 2/3 of that power's got to get rid of.
Mm.
Okay, we'll go to the presentation again.
Back to here and keep going.
So the next option is to improve receiver performance, and if next slide, the receiver performance interacts a bit with transmitters because you've got to have the spectral response that matches.
Yep.
The APD that I use, which I've been very happy with, it's a large area APD, and you do need a large area because it picks up a lot more photons.
Yep.
And bear in mind, every time you double the area, you not only double the photons, but you get double that again in power. So received. So while I actually got a gain in going from the 627s, which were very close to the peak, up to the 655s, which were slightly down.
Yep.
And we don't know whether that was propagation was helping.
Yep.
The spectral response by going up to the 735s is going to go quite a bit down.
Yeah.
And so we don't know how that's going to work out.
Okay.
And there's no equivalent in APDs of a large area APD that
Higher up.
which runs at the infrared. So there's going to be a balancing
Yep.
trick there.
Yeah.
Next slide.
Oops. Next slide.
Now this is some tests that Richard and I just did comparing my original.
Yep.
All of these systems had 400mm by 400mm Fresnel lenses.
Yep. Okay.
And the original one was a single BPW34, which nearly everybody who starts in optical just uses.
Which is an infrared remote control photodiode.
Yeah. And with that, on a night when there was no cloud, so it was just
Yep.
scatter of particles and no variation at all that you could notice. So you can compare these, even though they were done at different times sequentially.
Okay.
The single BPW34 gave minus 26 dB.
Yep.
Putting 35 BPW34s together
Yep.
gave minus 6, a 20 dB improvement. Now it should have been more than that if in fact all the light was on them all,
Yep.
but I suspect because I have
It's a large area.
it's a large area that the ones around the edge
Yep.
were not getting
contributing too much.
and so I got a 20 dB improvement, which at the time I thought was wonderful. And then I went to the large area APD and I got another 15 dB improvement again.
Yep.
And that's only 100 square mils, so it's less than the 35,
Yep.
but it's all in one spot,
Yeah,
all
yeah.
right there
Yep.
in the
All
middle,
closely coupled.
in the
Yes.
in the middle of the lens.
Yep.
So I'm just sort of making the point that area matters.
Yeah. Yep.
But the area's got to be right where it's in the right space.
And that's voice communication quality, isn't it?
Oh, absolutely.
No, you'd be able to hear that.
Yeah.
Well,
Yeah.
it's really.
In fact, we did in those days make a pulse width modulator for them, and actually transmitted voice.
Yeah.
Okay. Now, since we did all this, and it's over 10 years ago that we did this stuff, and we sort of lost interest in it once we crossed Bass Strait, but because of Joe producing these new modes, it's encouraged us back into it. And Larry, as he does, whenever you ask him, talk to him about anything, he dives into the web and finds things.
Our resident research analysis.
and he found that since those days, there's something called a silicon photomultiplier.
Okay.
And this table compares the silicon photomultipliers, which this particular firm calls an MPPC,
Okay.
with an APD, the avalanche photodiode,
Yep.
and the all pin diode. And the important thing that I thought was the gain. The pin diode has a gain of 1.
Yeah. Okay. So that's the comparison.
The avalanche diode, depending on how much voltage you put on, and I actually put 400 volts on mine,
Yep.
has a gain up to 100. You can actually run them with much higher gains, but they tend to become temperature sensitive.
Yeah. Okay.
But that doesn't really matter too much as long as you watch that the current's not going up.
Yep.
And the new thing has a gain of 10 to the 5th, and some of them that Larry's found have gains of 10 to the 7th.
Yes.
Okay.
Now,
Which is starting to get up into the photomultiplier tube.
That's right.
Range.
now
Well and truly.
the areas of them are very small, and it's a question of whether this spectacular improvement of gain can compensate for the smaller area. And I'm sure there's a mathematical way of understanding this, but I think we will do it experimentally, and Larry's in charge of this particular project.
Cool.
And he's going to build one so that we can compare it with our Rebels, which are at the moment our primary standard, of which
Yep.
anything else, well, no, sorry, with the APDs in this case,
Yep.
which is our primary standard, to see if it beats the APD.
How much of an area of that big Fresnel lens can you condense it down to for concentration for collection?
It's a bit hard to know.
Yeah, quality of lens is issue. If it was a good quality Fresnel lens, probably down to, I don't know, 2 or 3 mil, in sort of
Gosh.
right down to, but that depends on your mechanics to be able to get it right in that point. But the problem, the reason I say that is we, and I remember Mike saying this, they got some Fresnel lenses from China or Taiwan or somewhere, which were just casts of other Fresnel lenses, not actual literally cast from a primary standard. It was cast from another lens, and those lenses were not very good at all.
Right.
So it really depends on the and also the stability of the lens.
I mean,
So-
the other problem with a very small area detector is the beam width then becomes proportionally much smaller,
Yep.
and you're not picking up. And if you, that's fine if you're doing it line of sight and just looking at one source.
Yeah.
But if you're looking at something that's scattered off clouds, which is a fairly broad source, particularly if it's hitting the clouds with a 5-degree beam width, then you're not picking up very much of it.
Correct. The
So-
pointing becomes important,
Yeah.
and the
Yeah.
geometry becomes important.
So over to Larry.
Okay, what's your next slide up here? All right, there you go. All right, this is simply a comparison chart of some average devices that are available. Yeah. If you notice that the PMT, the photomultiplier, goes up to 10 to the 9th,
Yeah. That's
and
what
the
I thought.
APD that Rex has goes up to couple, 300, and that's with a bunch of voltage on it. But also the photomultiplier tube, you're looking at 3 kV,
Correct.
and that might be exciting in the dark in the field.
Yep.
And
yes.
then, and then,
Believe me.
then we have the silicon photomultiplier on the right, which can have 20 to 40 volts, but you see it goes up 10 to the 7th actually.
Yeah.
So that's a serious little critter. And this is what one of them looks like.
cool.
And when you don't want to build a transimpedance amplifier
Yep.
on the output,
Okay.
they sell you one of these.
Which is actually built into the
Yeah.
device.
And they're
These are APDs, though.
These are avalanche photodiodes. Amplifier
yeah,
modules.
but yeah, okay, my mistake. But there is a similar device for the
I
silicon.
think the other one was an avalanche phototype
Yeah,
too.
I picked up the wrong one, but
Yeah.
they sell these with the receivers built in as well,
Right.
the preamps, if you will.
Yeah.
Okay.
This is some of the response curves, or some of the response. Notice at 660, where we're looking at is right there in the middle.
Cool.
So it matches the thing that Rex was concerned about. These are, in other words, the emitter and the receiving
And
sensing
actually
device
they-
will be matched.
They do better. They do better up in that 732 than the APD,
Yeah.
Yeah.
because the APD drops off a lot.
Now, in the original chart, you look at quantum efficiency and the conversion. The first chart that I gave you, the layouts. There's, keep going back. Sorry, keep going back.
Which
Another one.
back here.
Yeah, if you go to the right, or right there in the top line, quantum efficiency. These are rather extraordinary devices because some of them, ones that Rex referred to initially, are even used for counting a single photon.
Yeah. Okay.
And these things are ramped up in what's called over voltage, which takes them into an avalanche range, or I think it's called Geiger. So it
okay.
loads the whole thing up. It's like the old days when you had parametric amplifiers, where you loaded everything up and then the tiny signal kicked it over. So it's really amazing how it works, and rather extraordinary. This is a family of things from Hamamatsu, and this is this silicone photomultiplier, and
Well, Hamamatsu are
Yeah.
the primary photomultiplier
oh,
providers,
Yeah.
suppliers.
they're
Truly.
all over everywhere.
I've still got their catalogues.
Oh, okay.
Anyhow, this particular device goes up to 10 to the 6th.
Does it say what the area is? Active area?
I'm sure it does.
Is it 1.3 by 1.3 mils, is it? Yes. Effective photo active area.
It's 1.3 mils by 1.3 mils.
Yeah.
Um,
Hang on.
yeah,
So it's quite small.
right.
Okay.
And they make several different versions of it, if you will.
Made for Lidar. Well, there you go.
Yeah.
There's probably one in Ben's phone.
Yes, I think that's might be right.
Now, I wrote down 10 to the 6th, but if you notice the response over on the left, the spectral response further down in the chart, that's the 660 again. So it's dead flat in the middle of what we want. That particular subset, it's the same.
Go a little bit more, and it even peaks a little bit more.
Yeah.
Gives you a little bit more. So
This is a typical thing: gain, crosstalk probability, photon detection efficiency, and overvoltage characteristics. Isn't that nice? There's a chart like that. I knew you were asking.
we like charts.
Yeah. So if you look, the gain is enormous, and if you drive it more than normal, you get up to some pretty big numbers. What's that? 1.1 times 10 to the what?
Where are we looking?
Yeah, right there where your pen is.
Well, up here, it's
Yeah.
1.2 times 10 to the 6th.
Yeah. And that's over the standard operating voltage.
And that's the gain line there.
Yeah, yeah.
So, yeah, at 7, over voltage of 7 volts is 1.2 times 10 to the 6th. So, a million, 1.2 times 1.2 million.
Yeah. And if you look down a little bit further, there's a simple circuit. That is actually how they tested that. That is simply the device going into a scope.
Yep.
But if you notice that what they're doing on the left side, that is nanoseconds. So the little critter's got a fast response, although I don't think that Rex is
I think we
with
do right
1800
around
second periods. He's
What,
probably
what size is that resistor at the bottom?
50 ohms.
Yeah.
50 ohms.
Yeah.
Okay.
And
That's
here-
quite different to what we've been dealing with. 10 mega ohms.
And having to have them in free air,
Yeah.
free space.
Right, now this is what's interesting because this is an operational circuit on a sample circuit board you can buy. They send you a whole thing ready to go.
Oh, okay.
And
And
it's all done with microstrip to get the high speed, and SMA connectors. It's put us up into microwave. It's sort of.
Yeah, so it's, I don't know what the cost is. I'm waiting to have them get back to me. But it's all 50 ohms, and they have a fast response, which is out of the diode in some manner, and then the so-called slow response.
Code.
All looks pretty good to me.
Yeah. Very simple.
And this is what they're justifying all the investment in the. That's all about Lidar.
Ah, okay. And this is, I assume, vehicle LiDAR?
Yes,
Is
it
it?
is. Well, it's any kind of Lidar because they're actually using
okay.
they're actually using it to track packages, and then they have supporting barcode readers, so things go zipping around to Amazon warehouse, and they're doing all sorts of
But
stuff.
that works in our favour because that means they're a consumer product and the price will come down.
Yes.
Yeah,
So that it's not specialist research sort of
Yeah.
stuff.
the Hamamatsu information I brought is absolutely workable, and they are available, but they're not inexpensive.
But-
So what I'm looking for now is something from an English firm and a couple of others that I would consider more affordable.
Okay.
Because at the moment, a single Hamamatsu is $450 or something like that.
Which is sort of APD type price-ish, maybe.
Well, it's actually cheaper than APD.
It's about a third of
They were
APD.
about $1,200, wasn't
Yeah.
it?
Yes.
Yes, I seem to remember. And the photo multiplier tubes are not cheap either.
Well,
So,
not if you get them new.
correct.
So it's a work in progress, but I have a lot of data collected. So
Fantastic. All
and
right.
I've met some people. I've been on the phone with some people in Melbourne who are interested in what we're doing, and they are a supplier, so they should be able to make up at least the Cree part of this and supply things for us. So I'm planning on ordering something later in the week.
Oh, cool. Cool. That's excellent. Sorry, I'll bring Larry on. He's talking. I should be bringing him on. That's excellent. So, thank you very much.
Oh, good.
I look forward to the next instalment,
Yeah.
as do our viewers, I suspect.
Yes. Well, there's some exciting possibilities.
Well and truly.
Yeah.
And the two-way across Bass Strait is looking more promising.
Well, certainly, and it may be further than Bass Strait.
By the look of it, yeah, like Mount Wellington to Cape Liptrap. Yeah, that'd be impressive.
That would be.
Very impressive.
The meteorology is going to be the thing then,
Yeah.
getting the clouds in the right place, and
Over what, northwest Tasmania-ish.
yeah.
Yeah. So okay. Well, that is fantastic. Thanks, guys.
Yep, our pleasure.
Thank you very much.
Okay.
We will reset. And this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our ATV Experimenters Night. And wow, what a huge bit of research. So just phenomenal. Okay, we'll finish off with a bit more on the end-fed half-wave antenna. We've been going into a little bit of that just of late, last week and a few weeks before that. One of the things that I've been playing with the Ben kit, and I acknowledge, hello Ben, I see you on the chat channel, so thank you for staying online. One of the things that I have done, and I'm just going to do a little bit of an experiment here, because one of the things that I want to show you, and let's just go to, and just excuse me, this is an experiment. Let's bring this up and see whether I can show this to you. Now, let's go across here to here. Now we want that one, and we'll get this one is what I want. Okay, what we're looking at here on the screen is this is the NFED half-wave matching box with the no counterpoise. So this is with just the nano VNA plugged in to the, oh hang on, we'll run that again. And you'll see I'm holding the box there, it's connected to the antenna, and I'm moving it from my knee to the to off my knee, and you're looking at what's happening on the nano VNA when I'm doing that. And can I just say there is a huge amount of difference to moving it around, touching the box, touching the connection to the nano VNA. Hang on, I'll play that again, Sam. You can see here I'm holding it out away from everything, and you'll notice on the nano VNA when I go back to it and I then bring it across to my knee, and then I take it off my knee and watch what actually happens. The lower parts of it, very low down in frequency, obviously is affected the most, and the higher frequency tend to stay the same. It comes the 40 and 20 affected a little bit, not that much. The depth of those particular resonances changes dramatically. Now, in comparison, I then put a 0.05 wavelength counterpoise onto the little counterpoise banana plug that I put on there, and the bottom line is it makes a very little difference if I move the box around. I touch the box, I touch the connector on the nano VNA, and you'll see here, you can see the upper segments change a little bit, but very little change, absolutely very little change. We'll do that again just so that I can show you. You can see it's sitting on my knee. In that case, with the no counterpoise, it had been making a lot of difference. I then pull it off my knee, move it around, put it back on my knee, and absolutely nothing. So my interpretation of that is with the counterpoise, at least you get much more repeatable results. It's only a 0.05 wavelength counterpoise. And at 40 at the lowest frequency, so at 40 meters, that's just over 2 meters. It's just a 2 meter piece of wire that sits on there and gives you much more repeatable results. Now, the other little video I've got here is somebody asked me around. I put a variable capacitor on this my box and asked me what the particular effect of that capacitor was on principally the higher frequencies. And so what I did was take a little bit of a video of, and what I'm doing here is changing the capacitor from maximum to minimum, so that you can see the 40 and 20 don't change that much. The 20 probably becomes a little bit lower SWR, but the 15 and 10 meter segments you can see change quite dramatically. The 15 comes into a reasonable SWR, and you can get the 10 meter down to probably around about 1.6, 1.7 to 1. if you play with it, I'll just play that again, just so that you can see. So this is the difference that variable capacitor actually makes, and it's in that you can see that changing quite dramatically in that 15 to 10 meter segment of the NFED. The 40 and 20 doesn't change that much, but the 15 and 10 certainly do. So anyway, that's the effect of the counterpoise, and also the effect of putting the variable capacitor instead of just the fixed capacitor in the VK7BEN kit. So if we come back to here, now the next thing I tried, which is now let's zoom in here a little bit. The next thing I tried was the particular configuration of the antenna. Now this is purely the effect that it has on characteristic impedance. This is in its configuration as a sloper, so I've just got the squid pole at one end, and then at the low end I've got the matching box. And you can see with all these are with counterpoise, the 0.05 wavelength counterpoise. You can see 40 and 20, fantastic. If they are below that lower line, then they're below the 1.5 to 1 SWR. For the 15 and 10, yeah, 15's marginal, and 10, yeah, you'd probably want to do some capacitance changes, vary the capacitance. At the maximum, so this is going the other end of the capacitance, the capacitor. You can see again the 20 becomes absolutely fantastic. It's down at almost 1 to 1. This is still under 1.5 to 1. The 15 is under 1.5 to 1, and the 10, you have to play with the capacitance and bring it somewhere in the middle to bring that down to an acceptable level. But that's in the sloper arrangement. I then changed it to a inverted V arrangement. So with minimum capacitance, and you can see the effect it has is it actually makes the slightly narrower in actual peak width for each of the resonances, a little bit. The 20 meter on minimum capacitance does tend to disappear, and it sort of progresses up on the 15 and the 10. If I go to the maximum in the inverted V, you'll see suddenly I've got it's okay on 40. It's well and truly come right on 10. It's almost right on 15, and 10 has almost disappeared as an actual resonance here. If you do a bit of a variation with the capacitor, you can bring 10 down to something that's near acceptable in an inverted V. But the key thing with the inverted V is it actually the key thing it does between the sloper and the inverted V is you'll see you have much narrower frequency response here. So it's just interesting observation, just a little bit of an interesting observation for each of those. So I do really want to change and actually do some contacts with the inverted V, because the inverted V of course puts that higher current right in the middle up at the high part of the antenna, and it also, when you invert a dipole, so you have an inverted V dipole arrangement, the inverted V actually brings that characteristic impedance down to somewhere near 50 ohms from the 72 that it is as a normal dipole. So it's sort of it is giving you a little bit more of that effect, but I would like to now try to make some make some contacts in both the sloper and also the inverted V and see what the difference is. So anyway, that's a little bit more experimentation in the end-fed half wave. I've also started to do some experiments with Steve Yates, who is the AA5TB, who I was referencing in last week. I have built up an equivalent circuit to what he uses, which is the variable capacitor, the 29 turns and the 3 turn unun that goes off to a BNC, the ability to put the counterpoise on and also the antenna on, and I'm just doing some playing with that right at the moment. You can see this is initially what I'm finding. I do need to play with the length of the antenna. It has quite a pronounced lower frequency resonance, which is interesting. Much less in the 15 and the 10. The 20, 15 and 10. So there needs to be some work done in that space. But anyway, just playing with a slightly different arrangement. This also cuts out the ground connection between the primary and the secondary of this transformer. So it is solely reliant on the counterpoise. So the common mode currents back down this cable should be next to nothing, I would hope. But anyway, just a few more experiments with end-fed half-wave antennas and how we use them. So there's still a bit to go. So watch this space. So anyway, we're at 9 o'clock. So I might wrap it up at that. Pardon. I just choked on something. Our videos for tonight, absolutely fascinating video tonight for our RF viewers. We start off with one that I came across, which is from Will Camp, who's a Tasmanian filmmaker, which is an interview with the man that runs the Skyline service station up at South Hobart, which is up on Hewan Road, which is a fascinating and quite humorous video, which has just been released in the last week.
Procrastinatorium.
Sorry?
Procrastinatorium.
That's the Procrastinatorium, yes. That's Nev Servo. So that's he goes into that. He's got some very interesting views. Then ham radio 2.0, the best HF ham radio under $1,000, and also a little short one about what a ham radio hotspot is all about, and we'll use a hotspot in a sec. Off the street, one by VK3YE, we might get to that one. We might not, might leave it for next week, but VK3YE, Peter Parker, does do a bit of a scan of his suburb around the hard rubbish collection and what you can salvage from the hard rubbish collection. So these are his electronic finds in 2020. And then an end-fed half-wave antenna tips and tricks, which we probably won't get to. We'll run out of time tonight, but we might bring that in next week. Now, next week we have Graham Wilson, VK7RE, who's giving us a presentation up here, which will also be pardon. I have a frog in my throat. So next week's presentation night, we will be broadcasting and we will be streaming it. So that's what we'll get up to next week, and then we'll head into our DATV Experimenters Nights with a Working from the Shack series interview for the second Wednesday night. So and then back into our DATV nights. So that's our program for tonight. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our ATV Experimenters Night, and we'll bid you farewell. And I'll go off and take some callbacks on our R2 and DMR and our YouTube streaming channel. Yeah, I agree, Ben. That's why I played it a few times, the videos. So yeah, they tend to be jumping around a little bit. I think there might be a bit too much going on this PC. Anyway, so I bid you farewell, 73. We'll catch you next week at our presentation night. This is VK7OTC 73.
Yeah, do you know Stephanie Haynes in the harps?